We're going to go ahead and take a look at number 61 from section 3.2 on quadratic functions. This problem is an application problem dealing with architecture. So what I suggest that you do is to have the book out and open in front of you and make sure that you have something to write with and on so that you can jot down any important information that you encounter as we read through the narrative. So number 61 reads, a parabolic arch has an equation of x squared plus 20y minus 400 equals 0, where x is measured in feet. We want to find the maximum height of the arch. First off, the author decided to make this problem a little bit more complicated on you. Before you can actually start working on finding the solution for the maximum height for this piece of architecture, we need to actually rework the structure of this problem. Notice that you have all the variables located on the left-hand side. And if you look at previous problems or previous homework problems, especially from this section, every time we've graphed something or analyzed the maximum point on a parabola or the minimum point, in other words, the vertex, y has been isolated to one side. So I'm going to go ahead and take care of that first. I want to get it so that y is alone. So really the way that this problem should be read is you can either write it as negative 1/20 times x squared plus 20, or you can write it as y is equal to x squared over 20 plus 20. I want you to note that the first term, your leading term of either negative 1/20 times x squared, is the same thing as x squared over 20. If you were to rewrite that and test it as a multiplication problem of two values, that's why you would get that x squared over 20. So in order to find the maximum here, we want to find the vertex. This situation that we have here, we can either treat this as if it were in vertex form or if it were in the general form. Okay, so what I would suggest doing is we can kind of verify this using our shortcut of x is equal to negative b over 2a. So let's pretend that this is in general form first. Okay, so let's identify our b. Well, in this case, our b is going to be 0, and our a is going to be negative 1/20. If we were to clean this up, negative 0 doesn't make any sense, so we'll just say that it's 0. 0 is neither positive nor negative, so the negative sign just kind of goes away. It's almost like you did a negative 1 times 0, so that's why you can get that 0 out. And then below we would get 2 times negative 1/20, that becomes negative 1/10. And you might think, oh, great, I have a division problem that involves fractions. So I technically, when you have 0 over negative 1/10, that's really a problem that's stating 0 divided by negative 1/10. But 0 divided by any number, whether it's an integer value or a rational number or an irrational number, it will always come out to the same solution. So this is 0. So in order to find y, we will go ahead and plug in what we know for x. And notice that 0 squared is 0, and 0 times anything is 0. So we have that y is equal to 20. So our vertex is 0, 20. We want to know what the maximum height of the arch is. Well, in this case, we know that the maximum height will be 20 feet. Okay. So there you have it. basically whenever you are presented with problems asking you to find the maximum or the minimum on a function that is a quadratic, or in other words, the graph is a parabola, you are going to want to focus on finding the vertex, because if you have a parabola that is opening downward, well then you can argue that the vertex has to be the highest point on that parabola. If you are working with a parabola that is opening upward, well, you can say that the vertex is the lowest point on this parabola. Okay? So hopefully this was helpful. If you need any additional help, please come see me.